This resume was analyzed by an AI system I built. It compares it against the job description, scores the match, highlights missing skills, and generates a structured improvement feedback. But this isn't just an API call from the front end. Most AI projects work. But if you showed their architecture in a serious backend interview, they would fall apart in 5 minutes. This is what the difference actually looks like. Let me show you how this actually works. So first we will upload the resume, and now after uploading the resume we will go to the new scan and we will paste the details here. So I'm using a LinkedIn job here, and, and then click analyze. So here you can see we have our uploaded resume and we have an analysis which is queued. If you see the worker, it is already running, like it is always running. It will just fetch the queued job. So here you can refresh it. Now you can see the job status has changed to processing, and here also it has fetched the job. Here you can see job has started. In database, now the job is completed. If you go to the front end, you would have to refresh it, and now we got the update. So here you can see we have all the scores and we have all the data I have showed you earlier. Linear implementations block the request and wait for AI. Production systems separate user interaction from heavy computation. Now let's zoom out and look into the architecture. This is a production ready AI SaaS architecture, and this resume analyzer is our first case study. The system does 5 core things here: accept user input, process it asynchronously, call an AI model, store the structured output, and track cost and usage. The last part is where most tutorials stop thinking. The user interacts with Next.js frontend, no heavy logic here. Then, from the front end, the data is stored into Supabase. It handles authentication, database, and storage. Then, when user clicks Analyze, we insert a row in Postgres table. That table acts as a job queue. Now, a separate background worker polls the database and extracts the queued jobs. Now, the job goes into the AI model. Then, it returns the result and stores it into the database. And then finally, the front end display result is shown and updated. This separation of concerns is what production systems require. Most AI projects look like this. They have a user which interacts with front end calls the API, and then you get the response. That works for the prototypes, but it breaks under load. Long request times, data rate limits, duplicate retries, and no observability. If your GitHub looks like this, you are signaling I followed a tutorial, not that I understand systems. We use PostgreSQL itself as a job queue. Workers fetch the job using for update skip logged. When one worker claims a row, that row gets logged. Other workers will automatically skip it. This allows safe horizontal scaling without duplicate processing. Understanding concurrency control like this is expected in a serious backend environment. Imagine an interviewer asking, how do you prevent duplicate processing when two workers run concurrently? If your answer is silence, your project is not built for scale. Each job moves through the defined states: queued, processing, completed, or failed. The UI does not guess, it reacts to the state changes. That's clean system design. The worker's responsibilities are very clear: poll, claim job, call AI, stored structured result, and lastly, update job status. The front end stays clean, compute happens independently. AI products without cost tracking are financially blind. Vlog, input tokens, output tokens, model used, and processing time. Engineers building scalable AI systems treat cost as system metric, not the afterthought. This architecture applies async processing, concurrency safety, clear state transitions, observability, and horizontal scaling. These are the signals interviewers and companies look for when evaluating backend and system capability. In the next video, we will break down database schema and exact job queue implementation. This series is focused on building production ready AI systems that reflect senior level engineering standards. If you want to build AI projects that don't just work but actually signal serious engineering capability, follow this series. That's all for this video. We will meet in the next one. Till then, bye and take care.